Hello everyone. So today we're going to talk about piecewise functions, and then we're going to connect that with our topic right now in calculus, which is limits. Alright, but first, I know a lot of you, I think all of you actually, haven't talked about what a piecewise function is back in the hybrid course from last year. So we're going to talk about this now. Alright, so what's a piecewise function? So just like in its name, right, piecewise, like piece, and then function, it's a piecewise function is a function made up of multiple pieces, shocker, right, where each piece has its own interval. Okay, and so these intervals tell you which piece of the function to use for specific input values. Okay, so here you can see an example of an actual piecewise function. So here, looking on the right, you can see over here f of x and how it's defined. And here you see each of its pieces. So here's our three pieces. And so it says to use the function x plus 3 if x is less than negative 2. And to use negative the absolute value of x plus 5 if x is in between negative 2 and 3. And then to use x minus 4 if x is bigger than or equal to 3. Okay, and then of course on the left you can see the part that's highlighted in red, that's representing our first piece of the piecewise function. The part in blue is the second piece, and then the part in green is the third piece. Okay, so all they're basically doing to actually graph this piecewise function is, for the first piece, they're just taking values that are less than negative 2 and plugging it into the function x plus 3. Alright, so for example, negative 3, right, is less than negative 2. And if I plug that in, I would get 0, which is why we have the coordinate negative 3, 0 plotted on that red piece there. And you would just keep doing that, right? So for negative 4, if you plugged in negative 4 into x plus 3, you would get negative 4 plus 3, which is negative 1, which would give you this point, and so on and so forth. Alright, same idea for the other pieces. Again, just paying attention to where the interval is telling you, right? So for the second piece, it's in between negative 2 and 3. And then for the third piece, it's everything bigger than or equal to 3. Okay. So what we're going to focus on more in this course is, of course, looking at piecewise functions, knowing how to, knowing function evaluation using them, and then also with limits. Alright, so in an algebra course, what you'd basically do with piecewise functions is usually you would be given one, and then you would do something like in the example where up here where there's a graph of it. So basically you would do a lot of just like graphing piecewise functions. But here the calculus, what's helpful is we don't actually have to graph it. When we compute limits, we can get an idea of the behavior around the point without actually having to graph the whole thing. Okay, so here it says complete the following parts for the function g of x, and of course here you see this is a piecewise function with 3 different pieces, and the first part here is asking us what's g of 2. Okay, so remember this part, this is our input, right? 2 is our input. In this case, it's our x value, right? Because the x's are our inputs, and then what we get out when we plug in our input is, of course, our output. Okay, so here I need to figure out what piece to use when x is equal to 2. So now I want to go over and look at these intervals, right? And see which one has, with these inequality signs, the little bar under it, meaning that it's equal to. Well, the first one does, right? This piece here has that x is less than or equal to 2. So when x is 2, I'm using this piece, right, of the function x squared. So g of 2 then is going to be 2 squared, which is 4. Okay, so all I did there was I plugged in 2 into x squared, alright, because that's where the function is defined when x is 2. Okay, now for g of 4, you want to try and figure out which piece you're using. Okay, so try to pause the video now and try to figure out what g of 4 would be. Okay, so coming back now, right, looking at these pieces, okay, we saw before that we were using for g of 2 what I highlighted in yellow. Right now, let's try to find the piece that I need to use for g of 4. I'm going to highlight that in green. So at the bottom here, we see that x is greater than or equal to 4. So that means when x is 4, I'm going to be using this piece. And this is just a constant function, right? So basically what it means is that when x is bigger than or equal to 4, my output is always just going to be 4. So there really is no plugging in involved that I have to do at this step. I'm just going to say that because when x is greater than or equal to 4, I have this piece 4, that g of 4 is just 4. Okay, because again, the 4 is my input, and so I would be using what's in the green there to get g of 4.